All right, in this video, we're going to talk about this infinite limits and vertical asymptotes. So in specific, a lot about vertical asymptotes. So some important concepts and facts to remember. This is when we're talking about limits. So if I have a number divided by something really close to zero, we're going to say this is infinity, like positive infinity or negative infinity. Now, this is not a number divided by zero. We're talking about limits. So if I have like a number over something really close to zero, like 0.00001, and if the top was in specifically, let's just say the top was the number 2, that would give us a really large number. So we're gonna call that infinity. If I had like 2 divided by negative 0.00001, that we would call that negative infinity. So I've got a number. It's like the number on the bottom is really tiny. Then the number on top is, or the number as a whole is really huge. Okay, the opposite's also true. So if I've got a number on top, a fixed number, over a gigantic number, we're just going to say that with limits is going to be 0. If I've got an infinity over some fixed number, that's just going to be infinity. And then these are still our indeterminate forms. So that looks kind of weird at first, but hopefully when we talk about limits here in a second, it'll make more sense. So it says when finding limits, if we have a number divided by 0, we need to know if we're dividing by like a number getting closer to 0 from the right. So like a positive 0. So if I have like a 3, some random number over 0.00001, we're going to call that infinity. And if I had a number over 0 from the left, that would be like 3 over negative 0.000, a whole bunch of zeros, 1, would call that negative infinity. All right, so let's kind of tie this together. Hopefully it'll make more sense after we talk about this. This notation right here bugs me. Number divided by 0, you can't divide by 0, so it's undefined, but it's important to remember we're talking about limits here. So here's our two graphs. We have the f function and we have the g function, and they look kind of different. It says use the graphs. We want to use the graphs and kind of tie it together. If we didn't have a graph but we're plugging the numbers, what would that look like? So the key here is if I don't have the graph, if I just had this, I had no idea what the graph looked like, I still want to be able to find out what the limit is or what's happening at the graph. And then that's how we're going to tie in a vertical asymptote. Right here you can see there's a vertical asymptote at 1. And same thing for g, there's a vertical asymptote at 1. So keep that in the back of your mind. All right, what is the limit of the f function as x approaches 1 from the left? So from the left, I'm getting closer to 1, that gives us negative infinity, right? So this is going to be negative infinity. But I want to use that like number over 0 from the left or 0 from the right. So if I'm looking at this and I'm plugging in 1 from the left. So think of numbers that are close to 1, but on the left side of 1 on the number line. So it'd be like 0.9 or even closer to 0.99 or 0.9999, a whole bunch of 9s. So if I was to plug in a number from the left and looking at limits, I've got 1 over, so it's a number, I'm plugging it up here. 0.99999 minus 1 is getting really close to 0, but it's negative, right? So a number less than 1, minus 1. So that's why we're saying it's getting closer to like negative 0 or from 0 from the left. That's why it would be negative infinity. If I want to find the limit of f of x in part b, as x approaches 1 from the right, I can see that my graph, it's getting huge because as I'm plugging in numbers really close to 1, but just to the right of 1 on the number line, that would be like 1.01 or 1.0001 or 1 point, a whole bunch of zeros, then 1. So that's 1 over 1.000001 minus 1. And that will give us 1 over 0.000001. So that's a really huge number. So it's 1 divided by a tiny number. So overall, this number is getting huge, and it's getting huge to positive infinity. So it's that idea of 1 over 0 from the right. All right, so the limit of f of x as x approaches 1, the double-sided limit, well, one of them is negative infinity, one of them is positive infinity. Those don't match, so we're going to say d and e. Does not exist. The left-handed limit does not equal the right-handed limit. Therefore, the double-sided limit doesn't exist. All right, next one. Let's look at g. All right, so this g function is still a vertical asymptote, but from the left and from the right are both positive. So if I have the limit of g of x as x approaches 1 from the left, so I'm thinking of plugging in numbers really close to 1, but just smaller than 1. So like 0.99 or a whole bunch of 0.99999s. So this time it's 1 over 0.9999 minus 1 squared. But that squared is going to get rid of that negative, right? This would be like negative 0.00001. Don't check that. I'm just making up zeros and nines. It doesn't matter. Okay, but that squared changes this. So it's 0.000000. Some huge number, but it's positive. So we're going to say this is equal to infinity. And I can see that from the left, it's going up to infinity. But that's that idea of a number over 0 from the right. So 1 over a positive 0. Like the 0, that's weird. That's positive, right? All right, same thing over here. If I plugged in a number just bigger than 1, so a number on the right side of 1, so like 1.0001 minus 1, that would be 1 squared of 0.00001 squared, which is still a positive infinity. So it's still 0, a positive 0. All right, so this time, this one we can argue back and forth, and I would, whatever argument you had, I would say you're right. The limit from the left and the limit from the right is equal to infinity, but what we're going to say is that this limit, you could say it's infinity, or you could say it doesn't exist, because the limit is unbounded, so it doesn't exist. If you want to say, well, the left-handed limit is equal to the right-handed limit, so they're both infinity, I'm okay with that also. Today I feel like D and E is better, but yesterday I kind of felt like infinity was better. The concept behind it's more important, and it won't come up on the AP exam. I don't think that'll be a problem, but I would just say D and E. I feel like D and E is better right now. All right, it says this little think about it. What do limits that result in infinity or negative infinity tell us about a function? Well, over here, these all ended up being vertical asymptotes, right? Okay, but that isn't always necessarily true. All it tells us is that the y values are unbounded. Or in other words, getting extremely large. Or extremely like large and so like could be really big negative, really big positive, so in absolute value. It does not necessarily tell us that we have a vertical asymptote going on. One other graph that we're going to just memorize, and you'll know it, just go ahead and memorize it now, is y equals e to the x, so the inverse of the natural log. So that one, there's a horizontal asymptote along the, I don't know why I did that. There's a horizontal asymptote along the x-axis. So the dotted line would be there. And your graph starts at, there's a point there at 0, 1. So the limit as x approaches infinity of e to the x is equal to infinity. So it just means it's growing without bound, but that one does not have a vertical asymptote. So there's a little trick there, which we'll talk about in the next video. But hopefully this kind of makes sense. This idea of dividing by a number divided by a number really, really close to 0, we're going to call that infinity. And that idea from the left and from the right, positive 0, negative 0. Helps you with that. All right, go to the next video if you would like more help with the next page.